3D printers allow hackers and makers alike to create something from nothing. And today, we're going to dive into the basics of 3D printing on this episode of Cyber Weapons Lab. "3D printers are an incredible technology, and affordable 3D printers like the Creality Ender 3 allow pretty much anyone with $200 to get started 3D printing things that are pretty sophisticated. Now, 3D printing isn't completely straightforward. You can't just put any sort of plastic in here and get started right away. But today, we're going to go through the general steps anybody working with a 3D printer will need to go through in order to create their first print. And in particular, these steps will definitely pertain to open source printers like the Creality Ender 3. Now, if you're interested in this sort of thing, there's a lot you can do, and it's really exciting. There's tons of prints out there and lots of tests you can do, and even some functional prints that can add really useful things to your daily life, like maybe a part of your car snaps off and you need to replace a small plastic part, or maybe you just want to add something that you don't want to go to the store to buy that you find is available online. Well, all of these things are perfectly possible with a printer like this. It just depends on what filament you want to use and some other things like what type of bed you want and what types of prints you want to focus on depending on what type of printer you have. Now, to follow along today, I recommend you have a printer, hopefully a open source 3D printer like the Creality Ender 3. If you're looking for a list of suggestions, we'll also provide some in the article linked in the description. If you have any other questions, I recommend you check that out because we will go into depth on how to do some of these things and get a little bit more specific. All right, with that being said, let's get started. Now, the first step for setting up your print is making sure that everything is level. You'll want to make sure that you have the auto home feature turned on, so it will send the hot end to its home. And once that happens, you will be able to make sure that everything is perfectly level. So this will go down and hit the stop, which was basically a stop switch that's designed to let it know when it's going too far down. And as soon as it hits the very bottom, we'll be able to start leveling the bed using a piece of paper and the knobs on the bottom side of the 3D printer. Okay, now that it's reached its home, we can take a piece of paper and put it on the bed. Now, I've set this bed to heat up a little bit, so I'm going to try not to touch it so I don't burn myself. But basically, we want to be able to slide this piece of paper under the hot end, and it shouldn't burn it or anything. And then we're going to go and look at the screws or the knobs on the underside of the printer. You can see there's one here as well. And we're going to turn these screws to try to level the bed. And the way that we'll know it's level is when we have the hot end in one corner, as we do here, and we bring up the bed until it just starts to scrape the paper when we move it back and forth. So if we can move the paper back and forth freely, we know the hot end is probably too high above the bed. But once I reach down here, I can move the paper back and forth. And as soon as I feel it scrape, I need to make sure it's actually on top. Oh, the other thing that's a good idea to do is to disable the stepper motors so you can actually move the printer bed. All right, I disabled the stepper motor, so now I can just move the bed freely. Okay, so this is actually touching the bed. Let me see if I can. All right, so I've backed this off from the bed a little bit, and I can move the paper freely, like this. So now I'm going to continue turning the screws and getting the hot end closer and closer until hopefully it starts to scrape. Okay, there. So now I can't move the paper freely anymore. It's starting to scrape. I'll back it off a little bit. Now the paper's free again. Now at this point, it's really hard to move, so that's too much. If I have it like this, where I can't move the paper at all, then it means that basically it's not going to be able to print because there's not enough room. So I'll back it off and find where it just starts to scrape, which is about right here. And it's still, I can feel it, but it's not preventing the paper from moving. I just feel the pressure. Okay, so that one's perfect. We'll go ahead and do the same thing over here. I'll make sure, in this case I can barely move it, so this is probably too far down. All right, now I can move it perfectly. And then that is pretty good right there. I'll do the same thing right here. right now. Ooh, I can't move that at all. So I'll compress the springs a little bit. Now I can move it really easily. And now I can feel it scrape. That's good. And then let's go ahead and go to the final corner. This is really hard to move. Okay, and now it seems pretty level. So if I really wanted to check this, I could print a test print that's basically a bed leveling print, and that will make a big square here. And if anything is super, super, super not level, basically it'll be messed up in one of the corners and I'll be able to diagnose which corner is wrong. So, okay, now that I have this, it's about time to make sure that I have the filament correctly feeded in. So on the back, I can squeeze on a little lever and try to feed in the filament. And if it's working, then I should be able to push in a little bit and maybe see a little bit of filament come out. This is all the way pushed through the Bowden tube here and going in to this part. And this is mostly enclosed, but the hot end is right here. So I want to be careful not to try to touch anything around here. But also be aware, I have a heated bed and this can get really hot. I heat it up to about 90 degrees centigrade in order to make sure my prints don't warp. So make sure you're not touching the hot bed if you do heat it up really hot, because that can be painful. All right, so let's say we have a print that we want to do. I'm going to move this back here, and in the front of the printer, we have an area that has room for a little TF card or SD card or micro SD card, whichever. And you can plug this into your computer, put prints on it that you download from the internet, and then as soon as you have the G code, you plug it back into the printer, and you can access the little console to do all the steps of going through your first print, which we will go through next. Now the point of having a 3D printer is to print something, but there's a couple things that we need to do before we can get there exactly. Now the first thing we need to do is have a slicer program. And in this case, I recommend Ultimaker Cura because it's free and the printer I'm using is one of the default options, the Ender 3. So it's really easy to get started working with the available space and knowing what you can and can't print. Now I'm going to be printing this design today, but before we can really print anything, we need to have a design that either we've created ourselves or that someone else has created and posted online. And fortunately, there are a lot of different places where you can find online 3D files. So if I want to go to one of them, I highly recommend Thingiverse. There's lots of different things you can find. You can see this is the one we picked for today. But if you want to print something that's really interesting or functional, maybe a USB rubber ducky case. Here we go. So if we wanted to print a USB rubber ducky case, here's a perfect example of something fun. This is going to take a little longer than I want because it's going to be more structural plastic, and I want to demonstrate something else today, but I've actually printed this USB rubber ducky enclosure, and it's pretty cool. So, okay, as you can see, there's lots of functional cool stuff that you can find, and I recommend you just Google around for .stl files, which we can open up in Ultimaker Cura, and then set a couple of options in order to optimally print whatever it is we're going to print. And I believe today we're going to print a honeycomb vase. Let's see. Yes, we're going to print this. So this was one of the files that I just downloaded from, well, just one of our results here actually. Oh, I'm blocking it. And we can see some details about who made this, maybe some revisions, and I kind of want to show what most of these websites look like because it's really cool that here we can see our example. We can see that it's been made 77 times, which means we can see other people's make of this. And if you're looking for a 3D model to print, I really recommend checking out other makes of a model you're considering and see if it looks good or if it went well or if there's something kind of wrong with it. So here you can see a bunch of other people either remixed it or made it or did something with it, which is pretty cool. Remixing and then makes are usually actually pictures of the finished. Wow, that one actually looks great. Pictures of the finished print, and you can see any issues, or in this case, it looks really cool with some LEDs behind it. So I want to print this kind of more like light diffuser-like thing, but you can also see there are varying degrees of how solid this is. A lot of people are taking advantage of the vase feature, although some of these are more thick than others. So I'm going to show something a little bit interesting you can do to print structures that are really, really thin, a single wall, but that could also, if the print isn't designed to do that, cause some problems, which I intend to do. All right, so let's go over. If I want to download it, I can click on download all files, and then within the zip folder that downloads, I can find all of the files there, open them up in Cura, and then I'm here. So I have a pretty good amount of bed space to work with, and you can see this one I've done here is about 3 hours and 36 minutes. So that's a reasonably long print, but not too bad. What if I wanted to go really big? Well, okay, there's lots of options here, and they're pretty cool. If I click on preview, I believe then I can also see what this print is going to look like. So from the very start, I can go up and over and see that I have made this one completely hollow, and I can basically follow the path of the nozzle and see what the print will look like at any given time, even down to the very first steps. So we can see what kind of support structure will currently be used to support this really big weird shape. Okay, pretty cool. If I want to go back to prepare, then I can select this model, and then there's some options I have here. So I have the ability to move, so I can move this around on the bed. Let's say I have terrible adhesion in the center or a hotspot, I can move this over here as well and print it there. I can also right mouse click on this and center the model again, which is useful if you get your object kind of stuck over there. Let's say that this isn't printing right and you want to print it on its side. Well, you can select one of these axes and then go to the rotate, and then you can print it like this, which would be horrible. And you can then click on slice, and that'll basically plan the route of the nozzle to create this object. And we go from 3 hours to 7 hours, because this would be stupid to print on its side. We would have to fill it with support structure, and it would be awful. So because this has so much overhang, we can also go back well, I guess we are in the prepare. Let's do preview, I think. Yeah, so we can see if this was printed, it would need all sorts of support structures to avoid going directly over it. So, or to avoid having any portions that were directly over without support. As you can see, all the red portions would require us to have an infill, which would be unfortunate. So I'm going to go ahead and move this back. I will click on the rotate and then select which axis I want to rotate it around. Might be upside down now, I don't care. And we can also do some stuff like mirroring. So if we wanted to mirror it over here, who even notices, you know? You know. Anyway, we can do per model settings. We can also do scaling. So if we want to make this really big, we can, whoa, this is too big. Our printer can't handle it. But if we wanted to make this to the largest ability of our printer, and I think the height is really the limitation here. Yeah. This is the biggest we can make. I'm gonna venture to say. So, all right, how long would this be? It's 3 hours to do the smaller one. What about this one? Well, let's slice it. And it has to plan, it's like GPS for the nozzle. It has to figure out every stop this nozzle has to make to create this insane shape. 12 hours. So 12 hours to create this massive weird tube. Now, this would actually be even longer, but I've changed some of the slicing settings. So let's take a look at these and what they mean. Now, first we have the profile, and this is what kind of quality we want to do this in. And typically we want dynamic quality, which means we're reducing the amount of resolution, or sorry, we're increasing the resolution. So we're decreasing how high the nozzle goes each time we do a new layer. So it's able to be a little bit more precise. And it takes longer, but the quality is better. So I have it set to standard quality, but dynamic is typically what you want to print in. Oops, no, none of that. So then we also have the quality. So we can see the layer height, we can set that manually. The infill layer height, we can set that manually as well. The shell is how thick each wall is. So if we're not getting the strength we want, we can increase that, but it also makes the print take longer. We have the amount of infill. So this is the strength of plastic that's basically space that just needs to be filled in. That's not going to be functional in other ways. I have this set at 15%, and that's very low. So if we wanted to increase this and have something that might be under more force, we can set it at like maybe 25% or 20%, and that's usually a good way of getting strength out of the plastic without wasting unnecessary plastic. Next, we have temperature. And it's really important that we have a type of material selected. Here I'm printing in PETG. So I ordered this by accident, but PETG is great. I really like it. It is challenging to work with at first, but it's very rewarding because it's stronger than the common PLA that's included with this kit. But you can see here, I can select what type of plastic I'm printing with. It can be anything from ABS, CPE, HIPS, okay, all right, HIP. HLPS, I guess, nylon, PC, PETG, PLA, and then there's also different types once I select the type of plastic. So really, really cool. I can see, I guess these are some vendors of different, PLA Plus. Yeah, that's all really cool. So there's different types of things here that we can select if we know exactly the type of material we're using, and it'll basically prepare all the settings just for that material, which I think is really cool. So we have this set to 238, and that is writing dangerously. I did a print at 245 and I damaged my tube and possibly caused some cancerous chemicals to come out. So make sure that you keep this setting, at least if you're using anything with a Bowden tube, which uses Teflon in the tube that goes down into the heating element. Make sure that stays below 240, because if it goes above that, the Teflon will start to degrade, you'll damage, your prints will be messed up, you won't know why, and yeah, overall you'll have a bad time. Now your bed temperature is how you prevent the plastic from warping while it's cooling. So if you don't have a heated bed, then it's unfortunate because your stuff will tend to warp a little bit as it cools. But I recommend setting your bed temperature relatively high. I set mine to 90, which is at the high end of what the spool recommends, but I wasn't getting very good bed adhesion, so I heated it up a bit and I managed to solve at least a little bit of the curling. And when printing really dense prints, I find that curling is especially bad if you're in an area that's not, that has a lot of ventilation, basically that has a lot of airflow. Now we can do the speed that defines how long the print actually takes. I wouldn't mess with this too much. This is a good speed setting. We have cooling. Now the fan speed, I would say, should be dropped down to maybe like 80% when, if you want to avoid cooling, like too much warping while it's cooling. So if you're printing something that's going to be really thick, maybe have it at 80% or something like that. You can also turn off the fan until a certain height. So there's a lot of really fine controls here. Now support is really critical. You can decide what kind of support you want. And here, if you're getting, for example, I had a large print that ended up peeling up, you can use a brim in order to cause a different type of adhesion. So right now you can see this is just kind of built right into the bottom. There's no real support here. But if I select a brim and slice it, then what's gonna happen is it's going to build a layer of support all the way around this giant model so that even if part of this started trying to curl up, it would have a lot better chance at actually staying where it needs to go. So if I click preview, we can see the brim on the bottom looks like this. And that is all designed to keep the print on the plate. So we also have other stuff like a skirt. A skirt does nothing. I don't know why you would use a skirt. It just makes a line around it. A raft. Now a raft will also do a good job, but it uses a lot more material. And if we were to slice and look at the preview, a raft will basically make a much bigger thing around this that you have to snap off. It generally looks uglier, and it takes longer to print. But as you can see, that's really on there. I mean, if it were to pull up a little bit, it would really have to pull up not only, the bond between the plastic to plastic is pretty strong, so it would have to like pull up all of this plastic to really get away too much and totally ruin the print, although it still could cause some damage. But aside from that, we can also have no support at all, which is a dangerous game. But if you feel really good about your bed adhesion, then you can always give that a try. We don't have a dual extruder, but you can also use extruders that have removable support stuff. So they'll basically make it so you can dissolve the supports when it's done, which is probably very nice. And then there's also some special modes, which I won't go into because unfortunately I don't have them. But now one thing I've done is click on Spiralize Outer Contour. And I believe if we slice it now, we'll see that it's gonna take a pretty large number of hours to print this giant thing. But that's because I've selected Spiralize Outer Contour, and this basically will create a vase. It basically does a single layer all the way around, so we can look down into this and be like, oh, there's a single thickness wall all the way through here. And you'll see this is 11 hours and 56 minutes because it's the absolute minimum you can print. If I do this and slice it again, now suddenly I'm not telling it to only do the inside. It's kind of up in the air as to how much plastic is going to go into filling this. So if I remove that option, I go from around 12 hours to, let's see what it's going to be, 2 days, 10 hours, and 24 minutes. So this makes a huge difference, because we have this massive thing now that's pretty much like mostly pure plastic, and the infill will matter a lot. Like this is going to be totally different. This is like a very solid shape. So you can see the 2 days versus 12 hours, like that's 2 times 24 hours plus 10 hours. Like that's a massive difference. So just keep in mind, all of these will dramatically affect your print and change the amount of time it's going to take. So we're going to change it back to this. And then I have absolutely no intention of waiting along that long for a print to go. So we're going to do something that'll take like 3 hours maybe, We'll make this a bit smaller, boop, and let's try that. We'll slice it and see how long that would take. 2 hours, maybe a little bit bigger, huh? I just want you to see the ratio. I'm increasing it just a little bit, and we are going from 2 hours to now 4 hours. So now I gotta make it smaller. And of course, I'm just doing this by, I'm not using calipers. I'm not trying to make this super dimensionally accurate. I'm just going for basically an understanding of how much increasing this just a little bit is going to increase or decrease the print time. And here I can see, boom, we've got it. About 3 hours, 1 minute, maybe a little bit more. So this is more or less the print I'm gonna use. Now, in order to actually save this as G-code, which is basically GPS instructions for the nozzle to run a route that will do this, make this print happen as the result, I click on Save to File, and then I can name it here. So I'm gonna name this Null Byte Spaghetti Base .G-code. Now, if we have a problem, which a lot of people call spaghetti, and we have basically the nozzle not able to rest on top, or possibly some warping that causes the plastic to be too high or too low, we'll see some defects in the print. But we can work on fixing those in future episodes, or just by making sure that the bed is perfectly level, making sure the temperature is set right for the nozzle, making sure that there's no cold air hitting the print, and generally just trying to take small steps to reduce the little errors that we're very likely to see. Now, the last step for taking that file is to just put it on the, I think it's the TF card, the micro SD card that goes into the printer. And once you pop it onto that card, plug it into the printer, you should be able to go ahead and print this file. Now, to get started, after we've leveled our bed, we can go in and basically set everything up. If we haven't already, we'll need to make sure that we've set to auto home, which I'll do now. We're already there. Then we can go back to the main section, go to control, and this is where we can go ahead and start preheating our bed and preheating the hot end. So I'll go to temperature, and then under control, I'll set the bed to 80. And I'm going to set the nozzle to, let's say, 200. And this can go faster if you do that. And this will greatly speed things up as soon as we decide on what we want to print. Okay, so we've preheated everything. Now let's go back. We're gonna go to main, print from TF, and we can refresh if we want. And then we're gonna do the big PETG vase. And this is from the G-code that we made in the slicer. We'll select that. And as soon as we do so, then originally the printer would just start heating the bed, and as soon as that was heated, it would move on to heating the extruder. But right now, we've already set it to heat up, so it's heating both at the same time, and that's gonna get our print done more quickly. Now, this print is set for the bed to be at 90 degrees, and that's pretty high, but that's to avoid the PETG from not adhering properly to the bed. In general, we're kind of printing at the low end of what we should be with PETG. So because we're not printing with something that is fine with a lower temperature like PLA and might kind of resist warping, we need to make sure that we set the bed high to avoid the plastic kind of cooling unevenly and warping away from the bed and ruining our print. Now, there's a lot of things that can go wrong when printing a plastic like PETG that's sort of on the edge of what this printer can do, but after some work, I imagine that you'll find some workarounds the same way that I did. So once this finishes heating up all the way, you can see that the bed is slowly getting there. We're now at 60 out of 90, and the hot end is heating up a bit faster. We're at almost 200. Although it'll need to go all the way up to 238, which is 2 degrees below the maximum heat for this printer. So I've printed at 245 for 5 hours, actually I think more than 5 hours before, and I scorched my Bowden tube, which is really bad because in a confined area that can release some really toxic chemicals. So since it's made from Teflon, just make sure that you're keeping it below 240. I'm really being edgy with bringing my print up to 238, but I find that it prints, at least this particular PETG prints really well at that temperature. Okay, now that the extruder and the bed have reached the temperature that it needs, it should begin by printing a short test and then go on to printing our actual print. Now, if anything is going to go wrong, you might see it in this first strip that it does on the left side of the printer, so be aware and look out for any problems in the first part of the print, such as failure to adhere or any other issues. Once your print is complete, make sure the bed is heated, and then take a scraping tool, and you should be able to peel up the skirts or whatever other support structure you used, and then also peel up the side of the print. Carefully, especially on a print like this. There we go. Now, because I went pretty slow, it hasn't warped too much on the bottom, but you can see that there's definitely not a perfect print. There's a little bit of spaghetti that's come out, but otherwise, I'm pretty satisfied with the way this went. Now we can clean up some of this spaghetti stuff that's come out here on the raft, but in general, this is a pretty decent start. In order to fix this stuff, we'll just need to level the bed and make sure that everything is perfectly level next time. After your first print, take a look at the result up close. You might notice some spaghetti or outright holes in your print like the ones you see here. And this can be for a variety of reasons. One of them might be you're not getting very good bed adhesion. So for some reason in the early phases, these layers just aren't sticking together. Maybe the temperature is too low and they're just not sticking together, or it's expanding or contracting too quickly, which might mean you need to have it in a controlled environment or increase the heat of your bed or your extruder. Now remember not to go too high, but in general, if you increase how hot the nozzle is, if you're seeing stringing like this, you might get a better result. Although again, just be careful not to go too high on how hot you make both the bed and the extruder. The point with making the bed hot is it keeps the plastic hot longer and prevents it from contracting and warping. And if the plastic starts to warp or cool unevenly, then it won't be able to support the layer on top of it, and you'll start to get some of the holes that you see here. But all in all, for a first print of just a little light diffuser that doesn't need to be watertight or anything, this is a pretty good print. So the next step would be to maybe print a big square and see if my bed's not perfectly level, because that's another reason that something like this could happen. If you like this tutorial, be sure to check out our website, where we have hundreds of free articles and videos, as well as premium paid content like the Ethical Hacking Certification Bundle, which features pen testing with OWASP ZAP, WordPress hacking and hardening, and the CompTIA Cybersecurity Analyst prep course. Check out the link in the description below. Getting started with 3D printing is easy with printers like the Creality Ender 3 and other cheap open source printers. Once you find other people's prints on the internet, you can try them out yourself and then try scaling them and slicing them differently, and eventually move on to doing your own prints. Now, while this printer is incredibly versatile and can print a multitude of plastics, it doesn't mean it can print everything. So if you need a stronger engineering style plastic, then you might want to look at a more expensive printer. That's all we have for this episode of Cyberweapons Lab. Make sure to like, comment, and subscribe, and also make sure to never set your printer over 240 degrees Celsius or you will release cancerous fumes. If you got confused, check out the Null Byte link in the description for helpful hints like this, and I hope you'll join us for more Cyberweapons Lab in the future. We'll see you next time. Bye.